All right, the title of this lesson, it's a little vague, I guess. Area. We could be doing area of all kinds of different things. Okay, we've done area before. In fact, we had a whole entire chapter where we just did area of things. Would you remember that? Area of a triangle, rectangle, rhombus, quadrilateral, all that kind of stuff. Okay, but this time we're going to do area. Some of it's going to be similar, but the problems we're going to do today we would not have been able to do back when we did that chapter of area, because they gave you certain information on that other chapter that they're not giving you here. But since we've learned a little bit of trig, we're going to be able to use that in order to find the information that we're supposed to. All right, that sounded a little vague, as well as the title of this lesson, and they just call it area. But let's just go right to the example, and let's see what we can do. All right, so here's the first picture they give you. What is that thing?
That's a pentagon.
It is a pentagon. And it happens to not just be any old pentagon. All the sides are equal, all the angles are equal, so we call it a regular pentagon. Good, so you remember that stuff from before. All right, let's do this. Let's just read the question, and then we'll attempt to solve it. It says, find the area enclosed by the pentagon. All right? Do you remember how to find the area of a regular polygon? I don't know if you'll remember this or not.
It's like,
The area of a regular pentagon, it's 1/2 AP. Well, what in the world is the A and what is the P? Yeah, very good. So you do remember. And it's been a while since we've done this. So this is the apothem. And then what was the P? The perimeter. Yeah, that was the easy one. The apothem you don't hear about too often. So that one would be the one that's a little bit tougher to remember. But you remember this formula, don't you? Now you do after I wrote it down? Say yes, so you play along. Yeah, of course. All right, anyway, so we had that equation back, or the formula back when we did area of a regular pentagon. All right, so what in the world, first of all, let's do this. What in the world is the apothem? I'm gonna draw something here. Let's draw a little dot right there, okay? Yeah, so that's the center of the polygon, the regular polygon. All right, do you remember what the apothem is? We'll do it in a different color.
it was parallel to the
Parallel?
perpendicular to the side.
Yeah, exactly. It goes from the center, perpendicular to any of the sides. Just to make it easy, we're just gonna drop it straight down, okay? So that right there is the apothem. Put it in yellow. Everybody good with that? You know what the perimeter is, right? The perimeter is what? The distance around the whole thing. It's the distance around the whole thing if you add up all the sides. Exactly right. Okay, so if I add up all the sides, that's the perimeter. So all I got to do, now they haven't given you anything yet. We will in a second here, okay? If you know one of the sides, what do you do to find out the whole perimeter? Just multiply by 5, right? There's 5 sides. Remember, it's a regular pentagon, so all the sides are equal. So if I know one of the sides, then I can find the perimeter. We're basically halfway done, right? The problem is to find the apothem. But let's write down the stuff that they give us. All right, so they do tell you one of the sides. And this is the Pentagon in Washington, D.C., this example. You guys watching? This is the Pentagon in Washington, D.C. So these numbers, at least this number right here, is pretty big. It's 921 feet. So 921. And that's in feet. All right? So just knowing that number right now, we can find half of our answer. So what would we do to find something up here? What would we do? Yeah, find the perimeter. Okay, so it's 921 times what? Yeah, so let's do that. Times. Say it again.
4,685.
I said 5.
I'm just looking at the bulk here. All right, they don't write the actual number down. They just put 921 times 5. But give it to me again, Gavin. 4065.
4605.
4605. 4605. 0, 5. All right. So there you go. You got the perimeter. So now all we got to do is find the apothem. But they give you some other stuff. Let's see what they give us. Now they give it to you in. Oh, why would they do this? Anyway, they tell you. Let's see. Let me read this problem again. Find the area enclosed by the pentagon to the nearest tenth of an acre. If each outer wall is 920 feet long and 1 acre, and they tell you what 1 acre is. Why would they do that? Let's just keep it in feet. Is that all right? Let's just keep it in feet. Braden, you're going to be right here. You knew it was coming, right? First of all, you throw paper in my room, and then you mess around. Then you turn around when I put my head up like you didn't do anything. See? I know what goes on.
No, you don't.
Sure. I got that one, though, didn't I? All right, so what we're going to do is this. Yeah. Let's do this. So we got to find the apothem. So this is all the information they give us. That's it. They only give us the length of that side right there, and we have to find that yellow. Like, how in the world are we going to find that yellow?
The apothem splits the side.
It does. That's good. That's a good start. So let's do that.
Yes. Yes.
All right. So there's 921. Of course, this bottom right here is going to be 921 as well. And if you split that in half, what's that? 460.5. So that's 460.5. Okay, so that little bit right there of this triangle. Now, it's a right triangle, but we got to find some other stuff. Get it? Okay, the blue lines are equal to each other. That is true. Okay. Now, I put 2 lines in here, and I did that for a reason, because of this. We learned...
360 divided by 5.
Yeah. We could figure out what this angle right here is, couldn't we?
360 divided by 5.
That's right, because if you went all the way around, now they do this in the book. They take these blue lines and they extend it to here, to here, to here. Now let's just do that. We got time. Can I grab that? Yeah. All right, so watch. I went to here, and then to here, like that, and then to here. All right, so watch this. If I went all the way around like that, how many degrees is that? 360. Now remember, every one of these angles, see this one right here, this one here, this one here, this one here, how many of those are there? 1, 2, 3, 4, 5, right? They're all equal to each other, correct? And if you go all the way around, it's 360. So Gavin said, do what? Divide it by 5, right? So take 360, we'll write it down here, 360 and divide it by 5. And what's that, 72 degrees? All right, so that, see that white arc right there? Let's get rid of these blue ones. Just gets in the way. All right, see that white arc right there? That's 72 degrees. Now, remember what we're trying to do. We're trying to find that yellow line right there. That's the key to this problem, right? The area is not a big deal because the perimeter wasn't hard at all. Okay, it's the apothem. So the whole thing is 72. So this little angle right here is going to be what?
36.
It's going to be 36 because this is a it's an equilateral triangle. Well, at least it's an isosceles triangle, right? So these two sides right here are equal. That's what Gideon said earlier. So it's an isosceles triangle. So that must mean that this angle right here and this angle right here are congruent to each other, right? Because it splits it right in the middle. So if this is 36, or sorry, if the whole thing is 72, then this is 36 degrees. Everybody with me so far?
Yep.
All right. I'll tell you what I'm going to do. Just to make it a little bit easier for us to see, I'm just going to redraw it without all the other junk around it. And then it might not be to scale, but that's okay. All right, so what do we know on here? We know we got to find what A is, correct? And we know this length right here is 460.5. And what else do we know? We know this angle right here is 36 degrees, correct? Now, we would be able to, up to this point, we would have been able to do this back in the, when we did that area chapter. Agreed? But we would have got, I should say this, we would have been able to get this far. But we would have been stuck in the other chapter. You wouldn't be able to figure out what A is right now because you don't know what this length is. You don't know what this length, you only know one length, right? So you couldn't do Pythagorean theorem or anything like that. But Gavin, you said do what? Let's do some trig. All right, so let's find 30, or let's use the 36 since that's the one they gave us. We could use this one if you wanted to, but let's just use this one. All right, saves us a step. So what do we have? We have this one is what to the 36? It's opposite, right? This is opposite. And what is the A to the 36? It's adjacent. We have opposite, we have adjacent. What's our trig function? It's tangent. So it's the tangent of what? 36, right? Because that's the angle that we're dealing with, is equal to the opposite over the adjacent. Which one's opposite? 460.5. And which one's adjacent? A. Right? So this is the new stuff. Everything we've done up to this is old, but this is the new stuff. Yeah.
What do you start when you know it's time to have the bottom of the
Like right at this point right here?
Yeah.
Were you able to set it up? Do you understand how we set it up though?
Yeah, we use the angle, the adjacent angle.
Well, you take the angle that you're dealing with, and you look to see what the other two sides are. This one's opposite. This one's adjacent. So you go through the SOHCAHTOA thing, right? SOHCAHTOA, right? Which one of these has opposite and adjacent? That one does. So that's the tangent. So that's why I write the tangent of the angle that we're dealing with equals the opposite side, which is this, over the adjacent side. All right.
So between we would choose the growth for A, we would choose the adjacent A, right? And we'll be doing the adjacent angle.
Well, no, you start with an angle. Okay? You start with an angle. I could have started with this angle right here. But then I'd have to go 90 minus 36. That's just one extra step I don't have to deal with. They gave us this one, right? Or we figured out this one. So let's just use this one. So I use this one, and I see what the relationship of the other two sides are to this angle. All right? So if I'm looking at this angle right here, I'm looking at the other two sides. What is this one? This is opposite. What is this one? This one's adjacent. Okay, this would be hypotenuse, but I don't know the hypotenuse, and I don't need to find the hypotenuse. So am I going to use the hypotenuse? No, don't need to, okay? So I just use the two. One they give us, one you got to find, and that's how I know to use opposite over adjacent. So here's, I think, what the question you first had. How do I know whether multiply or divide? Well, look, I'm trying to, this is just, it's kind of like, I'm just going to do this. So I got to solve by A. I got to solve for A, correct? But where is A? A is on the bottom. Okay, so I don't want A on the bottom. I never solve for A on the bottom, do I? I always take the variable that I'm solving for and put it to the top.
So basically, A is on the bottom.
Yeah, I wouldn't even think. Don't think of it that way. I mean, you could technically. What you're saying is right, but it's too confusing. Okay, just go by your basic algebra rules. That's what I would do. Okay, don't try to learn what you think are easier ways to do it. You know what I mean? Just go back to the basics. So what's the basics of algebra? If I want to get this A on top, what do I do to this to get A on top? I multiply it by A. See, that puts it on top. Now, if I do it to the right side, I do it to the left side. Everybody see that? Ben, do you see it? That's why I multiplied by A, because it was on the bottom, and then I get rid of it by multiplying, put it on the top.
And so now we have to do.
So I'll tell you what, let me write this down so you don't get confused. Equals 460.5. Now, again, I'm trying to solve for A, correct? So A's already on top, so I don't have to move it. I got to get rid of the other thing. What's the other thing that's with the A? That tangent of 36. Remember, tangent of 36 is a number you could stick in your calculator and you get a number, correct? Right? So this is just a number. So what do you do when a number is being multiplied by your variable? You divide it, right? So I divide it by the tangent of 36. Then I come over here and I divide this by the tangent of 36. Now look what happens here. That canceled out. A equals, then you stick that into calculator. That's calculator work. So let's do it. Put it into a calculator. And I got to change to degrees every single time. There we go. At least I'm remembering now to do that. All right, so what do we got? 460.5. So 460.5 divided by tangent of 36. This is slow using this calculator because I'm using the mouse pad and it makes it a lot slower. 36. I like to close parentheses. I don't think you have to, but then boom, there it is. 633.8. So, whoops. 633.8. All right. Let me just move this over a little bit. Oh, there we go. So are we done? Is that my answer? 633.8? No, what am I trying to find? What did it say? Find the area. Right. It says find the area. And do you remember what the formula was? You probably have it written down. 1/2 the apothem times the perimeter. So it's just 1/2 times the apothem. What did we just find? We just found the apothem. So 633.8. We multiply it by the perimeter. We found the perimeter earlier, didn't we?
Yeah.
It's this one right here, 4605. So let's put that in there. Right there. Now, plug that in your calculator, and you should get your answer. Everybody try it. I'm going to write down what the book says. Hopefully it's the same thing. Yeah, 1459, 379. Is that what you got? Well, it might be off a little bit because, now listen, it might be off a little bit because instead of using 633.8, they used this right there, okay? So if you put this in for that, you'd probably get this number I'm writing down because that's the one they got in the book. Now it's area. But if you got a little bit, if you were a little bit off, right, and you did this and got an approximation and you put it in here, I'd be fine. I'm not going to be super, super picky. What'd you get when you use the 633.8?
I got 1459 and then I got
1459, 3 what?
324.
324. Okay. 0.5. So that would round to 5 then, right? Now look, it's quite a bit off, right? I mean, look, it's 54 square feet off just because you used a rounded number, right? But that's what happens. Remember I talked about not using rounded numbers and putting into like Pythagorean theorem and all that kind of stuff? That's what happens. When you're using really big numbers, you're going to be off by a significant amount of things. But they use the exact number instead of 633.8, right? They use that whole entire thing, and this is what they got. Now, if you did this on a quiz or a test, and I saw that you used 633.8 and you got it the right way, and you got this for your answer, I'd be fine with that. Everybody hear me on that? Okay. So this is acceptable to me in a high school math class. Now, if you're really doing real work and you're working on the Pentagon and you need to find out the area of this thing, then you want to get as exact as you possibly can. So I would put the exact value in for this. Make sense? All right. I mean, this is still rounded a little bit, but it's not, it's way different than this right here. But when you're talking about 1 million square feet, 45 or 44 or whatever it is, 54 square feet is pretty insignificant when you're talking about over 1 million and a half almost square feet. Would you agree? Yeah. So it's really not that far off, even though it looks like it is with these numbers. Agreed? All right. So that's what they want you to do. That's how they want you to do these. So it's really not much different than what we've done before, is it? It's just putting two things together that we've already done. So it's really nothing brand new. So that's kind of nice. We good? Questions on this? All right. Now, drawing the thing out, drawing it out knowing to go 360 divided by 5, for some people, they saw it right away. For some others, you're like, oh, what in the world do I do from here? I don't know. So you got to think about, oh, what do I know about regular polygons? Well, that's right. I know they're all congruent triangles in here. This apothem splits this into 2 congruent triangles, right? That means all these angles inside of here must be equal. 360 divided by 5 is 72. Then these are congruent triangles, so these 2 angles are equal. So you split that in half, and you get 36. Those are all things that you have to come up with on your own. You've got to think about it. You got to look at this and say, oh yeah, this is what I can do to get some angles. Question? We just found the area. Yeah, that 1.4 million. Okay, that's the area. It's square feet, right? What's that? A million? Oh, for an answer? Might be the first time we got over 1 million for our answer. So there you go. That's probably our biggest answer that we've gotten so far. But they are talking about the actual Pentagon in Washington, D.C. It's a massive building. It's a really big building. Okay? I'm not going to worry about the acre part of that. That's just going to confuse you more. If we had more time, if this is in the middle of the year, maybe we would do it, but not towards the end of the year. Okay, let's do another one. This time it's a triangle. So, looks like this. This looks about, doesn't go right in the middle, it goes about right there. And then this comes to here. All right, and then they, let's do this in a different color. They drop this perpendicular. Okay? All right, let's see what they tell you. They tell you that this is, let's go back to white though. There we go. They tell you this is 80, and this is in feet. I'm just going to put the numbers. I'm not going to put the units on this. That's 80. This is 90. This bottom is 110. And they tell you that this is 46. And this yellow one is called the height. They are not equal to each other, right? See if I drop this straight down. If these two sides were equal to each other, if I drop this straight down, it would be right in the middle of this bottom. You see that? But it's not. I mean, you can see this is significantly smaller than this one. So, and plus this is 80 and 90, so it's not an isosceles triangle. Okay. What am I doing? Changing this back to yellow and finding the height. Is that what they asked for? Actually, it says find the area. It doesn't say the word area. It says find the square footage. That's what it says. You hear me? It says find the square footage. Well, what is it really asking for when they say find the square footage? Yeah, it's the area, okay? It's like on that Pentagon. It was 1.4 million square feet, right? So the square footage is area. So we are finding area again of a triangular lot with sides 80, 90, and 110 if the angle between the two longest sides is, now they say approximately 46 degrees. All right. Yeah. That's really not that hard. That first one's way harder than this one. What do you think? Yeah, we got to find the height. And we also got to find what else? Yeah. And we also got to find the base. But we already know the base. What's the base of this whole triangle? It's 110. So the 110 goes from here to here. Everybody see that? So that's the 110. So all I got to do is find the height. Well, I've got a right triangle, don't I? You see this? I've got an angle, and it's a right triangle. So what is this side to this 46? It's opposite. What is the 90? It's the hypotenuse. So which trig function uses opposite and hypotenuse? It's the sine, right? So, katoa. So SOH is the sine. So I'm going to take the sine of 46, and that's going to equal what over what? Well, it's H in this case, but H, that's the opposite over the hypotenuse, which is 90. Now, look at the variable. Look at the thing we're trying to solve for now. It's on the top now, isn't it?
Yeah.
Okay, so I don't have to multiply it, right? Because it's already on the top. So really only one step. What do? Multiply by 90, right? So watch, you don't have to show it on that side. You know it's going to cancel, right? And then you just put the 90 right there, and that's the height. So how do I find the area? Tell you what, let's put this whole thing in. Let's don't put this in the calculator, get a decimal, and then put it back in. Okay, let's put the whole thing in. So the area is equal to, it's a triangle, so it's what? 1/2. The base, what's the base of this? 110 times the height, and what's the height?
90 times the
That's
sine.
it, 90 sine of 46. See why I didn't put that as a decimal? Because I want to put it in the calculator all at once, and that will give me my most accurate answer. So you should get 3560.7.
Yep, 0.7, yeah.
And then this is in feet. I didn't write feet, but it is in feet. So it's area. So it's what? Feet squared.
Why do we use the 110? Because it's the base.
It's the base of the triangle.
Why don't we use the 80 and 90?
It's not the base. Because the height and the base are perpendicular to each other. Remember, if you do base and height, whether it's a rectangle, whether it's a rhombus, whether it's a triangle,
I thought we used a polygon and no, it's pro.
that's only when it's a regular polygon. This is not a regular polygon. You only use 1/2 the apothem times the perimeter when it's a regular polygon. This is not regular. Regular means all the sides are equal, all the angles are equal. That is not the case here, is it? All right. So this is just a regular old triangle. So it's the base times the height. And remember, the base and the height have to be perpendicular to each other. We good? You what?
That'd probably be way off.
All right, I've got one more thing. Well, I got a couple things to teach you. This kind of leads you up to a couple formulas we're going to learn. I just don't have enough time right now to do those. So, yeah, I'll just give you the weekend off for homework, okay? So we will finish this up on Monday, all right? Because this is leading us up to something. And yeah, I just don't have enough time to go through all that right now. So we'll finish it up on Monday.